Hi everyone, my name is Gina Osborne.
I'm Mohammed Gerard.
And I'm Joshua Jeter.
Our technical advisor is Dr. Jose Macedo, and our project is streamlining the Embed management and tracking system for WebCore. WebCore Builders is a commercial construction contractor headquartered in San Francisco, California. WebCore is currently in the pre-construction phase of their 706 Mission Street project. This project development includes a 43-story tower and the rehabilitation and integration of the historic Aronson building, which will be the new home for the Mexican Museum. In past projects, schedule problems arise due to poor materials management, specifically with embeds. Embeds are pieces of steel that get cast into concrete in order to connect and weld other systems securely. There are three types of embeds: structural steel embeds, window curtain wall embeds, and miscellaneous embeds. Our problem statement is, WebCore construction projects commonly suffer schedule delays that result in extra costs due to a poor embed management system. Having a new system by August would ensure that the project stays on schedule and makes the construction workers and project managers' jobs as easy and efficient as possible.
A lot of our research resulted from interviews with employees at WebCore, such as project managers, project engineers, the financial department, and primarily the superintendent of the 706 Mission Street projects. We also visited the WebCore construction site in San Francisco and were led through the construction site by Steven Zetcher. They use one supplier for each of the three types of embeds. To order the embeds, WebCore sends a master schedule of the construction site to the embed suppliers at the beginning of the contract. The suppliers manufacture and deliver the embed orders by interpreting the concrete pour dates and the drawings that are in the master schedule. The quantity and the grouping of the type of embed that the suppliers deliver are usually not known by the general contractor, and after contacting suppliers, they are unwilling to negotiate a more structured system. For our online research, we researched peer-reviewed articles that include supply chain models, materials tracking, and materials handling logistics methods. To measure the severity of the embed management system, we created a survey on Google Forms, which was distributed to various WebCore employees that directly handle embeds, such as project engineers, project superintendents, and assistant superintendents. From this, we found that on a scale of 1 to 10, 1 not being severe and 10 being extremely severe, embed management is rated on a 7.2 on average. We asked what components of the embed management contributed most to the problem. We received the responses shown in the Pareto chart, which is how we decided to guide our solution to contain the three aspects, which are embed tracking, embed delivery, and embed handling. Some symptoms that result from poor embed management are embed installation in the wrong area, embed stored in the wrong area, missing embeds, delivery error, and low embed quality. These are all ways that the schedule could be delayed and range from short delays, such as 1 hour searching for the embeds, to a longer delay, such as 2 days reinstalling the embeds. 9 out of 10 WebCore employees said that the embeds are missing once a week, so it is easy to see how these delays could build up over time and lead to a delayed project.
Once the embeds arrive on site, WebCore takes note of things such as what embeds have arrived, quantity of embeds that are still needed, and what dates the embeds are needed by. Once they are back in the office, they use Excel or Smartsheet to document these things. WebCore creates a new embed tracking sheet before the start of each of their projects. Shown is an example of one of the sheets that are used by WebCore. This process is unable to perform real-time updates, does not take into account who received the shipment, wastes time taking down data twice, once on paper and another time into Excel, and is not standardized. In our literature review, we found the article Automated Inventory Tracking System Prototype in the Cloud, where we found that an option for WebCore could be using a cloud-based system to update their inventory of embeds. While on the construction site, each WebCore employee already has their own iPad, so we decided to limit our solution to software available on the iPad. Luckily, lots of software is already available, so there is no need to code our own version. Features that the application must include are availability on PC and iPad, exportability and importability, no coding experience required, and real-time cloud syncing. We tested various available software that met these criteria by viewing demo videos and downloading free trials and experiencing the software firsthand. We narrowed down our search to 4 options: Pocket Access, Zoho Creator, Ninox, and Navicat for MySQL. After that, we decided on factors that would be important to WebCore and weights for each of them based on information mentioned in interviews. After using a weighted decision matrix from IME 303 Project Management, we found that the best option was Ninox. It has a simple user interface and an intuitive design that satisfies all of WebCore's needs and includes extra features such as graphical analysis and templates.
After analyzing the delivery process of the embeds, we found that the most delivery problems stem from the contract negotiation. In this process, the project engineer creates the work scope form, which documents the agreement of work and the embed order details such as delivery times that the subcontractor will fulfill. The current way the contract negotiation is done is the project engineer drafts a contract, then emails it to the subcontractor, which then would be reviewed and revised, sending the contract back and forth through email until both parties approve, resulting in a long process. According to our research, the construction industry commonly lacks modern software tools. In the case of Malaysian construction companies, researchers found that the use of e-procurement and other softwares decrease costs and improve the overall efficiencies in their processes. So for our solution to eliminate long lead time waste in the ordering process, we researched many software tools that would streamline the negotiation process. Using a decision matrix, the top three software tools were selected and further analyzed, which are Evo, Aptivo, and Concord. These three top softwares are cloud-based and are compatible with any device. Each software was tested using a demo version and consulted with a representative of each company, and the analytical hierarchy process was used to make the final decision. Out of the three softwares, Concord was found to be the most effective in streamlining the ordering and contract process. Concord offers an excellent contract management feature that would allow webcores to centrally manage their construction and supplier agreements. All documents and engineering drawings are filed into each contract, and all parties are able to make revisions while keeping a track record of all edits, versions, and views of the contracts. Concord's internal validation workflow makes sure that each contract goes through the proper chain of command before getting signed. Communication is streamlined through the discussion panel of each contract, and automatic notifications and reminders can be set to the specific parties, which will significantly improve the ordering process.
The current problem with Webcore's on-site logistics is its inability to sort pallets containing embeds. Right now, Webcore employees don't label their pallets. If they were to label their pallets by floor, by embed type, and by element, it would be easier to organize and store the embeds. Based on our literature review, how to implement inventory management practices, our solution is to print custom labels using printer paper. We would then tape them onto the pallets. This is an example of what these labels would look like. Including these specific aspects would give Webcore employees everything they need to keep the embeds organized. Our solution would have the following delivery process, which is a technique learned in IME 443, Facilities Planning and Design. This materials management method will be used to standardize how embeds are received and sorted throughout the site in order to recognize delivery error early and to store embeds in the correct area.
To improve the embedded management system, we recommend the use of Ninox database software, Concord contract software, and the standardized embed handling process. Each of these solutions may be implemented separately and gradually over time, but we recommend using all three alternatives at once to have the greatest effect. One secondary impact is the organizational effects because employees will have to adjust to new software and new processes, and there could be a learning curve associated with our improvements.
The implementation cost is $4.33 daily, $100 monthly for the contract software Concord, and $30 monthly for the inventory management software Ninox. For each day past the projected completion date, there will be an extra $3,287 cost to pay the employees per day. To exhibit how important it is to remain on schedule, we used Webcore's current 706 Mission Street contract to display the fees associated with being late. If this project continues 60 days past the scheduled completion date, there will be a $5,000 fee for each day past the 60 days until the project is completed. Reducing the length of the project by 1 day will be cost-effective and worthwhile. This 1 day delay is our break-even point because the cost of our recommendation for the entire duration of the project is $3,161. This is less than the $3,287 employee cost of being 1 day late.
One option that we developed was an embed just-in-time order delivery schedule decision support system using the IME 305 operation research method, linear program modeling. Unfortunately, we found the solution would not be helpful due to suppliers' unwillingness to negotiate just-in-time shipments and because of the high variation of embed supplier times. Another option we did not explore is RFID tracking or barcodes. This could potentially be an option in the future because Ninox is compatible with barcodes depending on the supplier's willingness to label their embeds this way.
In conclusion, our recommendation will effectively streamline Webcore's embed management process. This is capable by implementing the Ninox database management software, which will improve the embed inventory management and tracking by eliminating waste that exists in the current process, such as waiting, overprocessing, and defects. The Concord software streamlines the ordering process by making the contract negotiation with subcontractors faster and easier to complete, significantly improving the supplier communication. And the standardized embed handling process standardizes and improves the embed inventory and storage process, reducing the amount of lost embeds and making WebCore employees' jobs as easy and efficient as possible. Thank you for your time and have a great day.